Hey guys, I'm going to do a very brief video on the idea of covalent bonding. So at the end of this, we should be able to discuss how covalent bonding differs from ionic bonding and recall what types of atoms are going to form our covalent bonds. So when we think about a covalent bond, this is a sharing of electrons. So it's formed by two atoms sharing a pair or pairs of electrons. Okay, so when we're thinking about covalent bonds, this is always going to be between two non-metal atoms. So it forms between two non-metal atoms. So our things on the right side of the periodic table. Okay, and anytime we have a group of atoms held together by covalent bonds, we call this a molecule. So a molecule is a group of atoms held together by covalent bonds. Below is the most simple of our covalent molecules, H2. H2, we have, if we look at our Lewis symbol of hydrogen, it has one valence electron, so it's written in only one quadrant. And then when it comes together with another hydrogen, those two valence electrons are going to be put basically in the same quadrant, and they're going to be shared between. And anytime we have two valence electrons coming together, so two valence electrons becomes a single line to indicate a bond as long as those two valence electrons are between two atoms. Okay, so our covalent bond, here again, we're still trying to achieve an octet. But instead of moving electrons from one atom to another, we share electrons. So we try to achieve an octet by sharing electrons between atoms. And we share electrons in order to get an octet. So if one atom contributes one electron, another atom contributes another electron, those two electrons are going to be shared between the two atoms. So it's basically they both have two electrons now instead of one. So every atom contributes one electron per bond. So two atoms, one electron each, gives us two shared electrons. If we have four atoms, four electrons each, then we'd have our total of 8 electrons. So I was just trying to get to that octet. We can see this if we look at two fluorine atoms. So two fluorine atoms, each of them have 7 electrons, and they have 1 electron each that is unpaired. They're going to share those 2 electrons between them, and now each atom has 8 electrons because you're going to count the shared electrons for both atoms. The length of that bond is going to be a combination of attractive and repulsive forces. So our bond length depends on attractive and repulsive forces. So our attractive forces is going to be electrons of one atom being attracted to the nucleus of the other atom. So there's only really one attractive force we think about with this. And then our repulsive forces, we have electrons from one atom repelling electrons of the other atom. And then the nucleus, which contains protons, of one atom repelling the nucleus of the other atom. Okay, so again, that balance. And we can see that if we look over at this figure over here. So we've got electrons repelling other electrons. We have protons repelling other protons. And then we have electron-proton attraction going on. And you're basically looking for an energy minimum. So we can look at the energy versus atomic distance. And we can have atoms either very, very far apart from each other. So we're going to call this A. Getting closer together, B. Our maximum bond length will be C. And then closer together, we're going to call that D. So we're going to start A over here. And then as we get them closer together, we're going to be at B. So increasing the energy. Decreasing the energy as we decrease the distance. And then we get to a energy minimum, which is our bond length. So the optimal atomic distance. And then if we try and get them anywhere closer together, there's going to be too much repulsion between the protons, electrons, electrons. So we get to our too much repulsion. So this is our bond length right here. Anything further apart is not as energetically favorable. Anything closer together is not as energetically favorable. So that's why it adopts a specific bond length. That is it for our very, very short video. We'll talk to you guys in the next one. Bye.